Welcome to TEC Talks, a podcast about the impact of technology on humanity. I'm Kirsten Martin, the director of the Notre Dame Technology Ethics Center, or what we like to call ND-Tech. In these discussions, we talk about an important idea, paper, article, discovery in tech ethics, and today I'm so happy to be joined by Ben Green. Ben is an assistant professor in the Ford School at the University of Michigan and a postdoctoral scholar in the University of Michigan Society of Fellows. He has a PhD in applied mathematics with a secondary field in science, technology, and society from Harvard. He studies social and political impacts of government algorithms with a focus on algorithmic fairness, smart cities, and the criminal justice system. So today we're going to take a deeper dive in this article in Philosophy and Technology called Escaping the Impossibility of Fairness, from Formal to Substantive Algorithmic Fairness. And I'll just say, I think my favorite part is figure 2, but we'll get to that in a little bit because I think it really is a nice visual as to the role of formal fairness. But I don't want to skip too far ahead, but it's great. And so I thought this is, in general, talking about this move from formal fairness or mathematical fairness to something more substantive. And so I thought maybe you could start with the problems that you identify rightly about the dominant approaches to fairness that relies on mathematical modeling and that gets us into this impossibility idea of fairness, where we see ideas of fairness as incommensurable, before kind of going to your solution.
Yeah, well, thanks so much for inviting me on. And I think that's a great place to start. I'm excited to have this conversation about this paper. Yeah, I think this paper really springs out of trying to figure out, where does the field of algorithmic fairness go? What is a positive agenda for this field? It has often been caught between sort of two camps. On the one hand, you have the computer scientists who say fairness is a problem. We can formalize fairness. We can create a definition for fairness. And then you have critical scholars in philosophy and STS and other fields that say, of course you can't do that. Of course you can't, characterize this very complex notion of fairness into a single mathematical metric. Here are all of these problems that arise when you try to do that. And so there's this sort of deep tension between what do we do, right? We can, on the one hand, there's these attempts to formalize the problem. On the other hand, there are critical scholars saying that approach doesn't actually get us that far. And one of the major issues that has come up through this formalization approach is what's been called the impossibility of fairness. And this is a mathematical result that sort of shows the incompatibility of different mathematical notions of fairness. And in particular, there's sort of the two major notions of fairness that often are talked about. The first being an idea of calibration, which is that people who are predicted to have an outcome at similar rates should be treated similarly. And the other notion would be something along the lines of equal false positive and false negative rates for different groups, saying that, if two groups are equally, if someone is not going to commit a certain outcome, then they should be treated similarly. There should not be more false positives or false negatives across different groups. And this debate came up most notably when it was really sparked by the ProPublica article about the Compass algorithm, their machine bias report that showed that this algorithm that was used in pretrial and sentencing made false positive predictions about Black defendants, saying that falsely predicting that Black defendants were going to recidivate at a much higher rate than the algorithm did for white defendants. And so it sparked this question of, how do you navigate between this tension of wanting to, get rid of these different false positive rates, but then that's in tension with, treating people the same based on their predictions. So that's really this impossibility result that has, I think, stymied the field's progress.
And I think it also has real implications. Like I feel it when I'm talking to people in the business school or anyone that's kind of looking at more applied data science, and they use this as a kind of excuse as to like, we're doing the best we can. And if I just have to choose one of these random mathematical definitions of fairness, and therefore that's what fairness is, And so I see that from the titles of the impossibility of fairness, people glom onto that and say, well, it's impossible. You know that, right? It's impossible that we can't do this. And so it's kind of had this downstream effect into applied work from the computer scientists, noting that if we say that we want to have the same types of mistakes that all people have error rates about the same versus good predictions about the same, that it's hard mathematically to get that to work. But that doesn't mean that we don't stop trying. Or in your case, to say maybe those aren't the right definitions of fairness, and that's not all there is.
Mm-hmm. Yeah, and that's a great point. And I think that was part of what motivated me to really dig into this impossibility result more fully, was having a lot of conversations like what you're describing, where computer scientists or even policymakers are saying, well, it's just a matter of trading one versus the other. We have to pick one, or we have to figure out the right balance. And that's really the best that we can do, this sort of shrug your shoulders, accept your fate approach, which on one level is mathematically correct, but I think felt to me like it was really limiting our ability to think creatively about how we could try to promote equality with algorithms.
Right. Yeah. And you do a nice job of saying, just that the problems with the formal, that one, we're ignoring these philosophical meanings, but we're also just naturally limited by the tools of the field, which I like your quote from Dewey, which I always misquote by saying a problem defined is a problem half solved, which is like the much shorter version of it. But the longer version, which you nicely quote, is the way in which a problem is conceived decides what specific suggestions are entertained and which are dismissed. And so we automatically, by defining a problem as a mathematical problem that we need to solve, kind of go to it with only those tools that we have. And then the answer we get, it's incommensurable, is the answer that we have. And we just stop looking, we kind of dismiss these other ideas. And your great point is, which is leading to myopic suggestions for how to promote fairness in practice, which I think we see the results of.
Mm-hmm. Yeah, and I think, a lot of this is, I don't get too much into, the Dewey of it all in this paper,
right, yeah.
But I think there's more that I've been thinking about and hope to write on, sort of bringing in Dewey's pragmatism into thinking about the role of algorithms and how we design algorithms, really shifting away from trying to focus on these abstract conceptions of ends in and of themselves. When from computer scientists trying to define fairness, then the conversation centers around the definitions of fairness, these mathematical conceptions, and even our arguments, sort of focus on that level to say, are algorithms inherently biased? Can we make fair algorithms? And it's very much focused on the algorithm itself. Then we have, because of the way that the problem is conceived. And what I am pushing with this article and some of my other work is to say that we really shouldn't be worrying about that mathematical construct so much, except to say, how does this actually affect the real world? How does this work in practice? Rather than asking, is this algorithm inherently fair or biased? We should be thinking more in terms of, to what extent do algorithms improve or hurt efforts to promote equality, right? Sort of shifting from a debate of, this represents fairness versus no, it doesn't, to how can we have algorithms that play more productive roles in promoting equality? And whatever we're doing on the formalization side is instrumental to that downstream goal.
To that goal, right. To kind of shift what the goal is versus a technical outcome is to say, what do we want to have in this decision space? Like, so what is our goal for this type of decision? And then have that kind of, filter downstream as to whatever. And it would almost become an engineering input of like the assumptions that you need to make.
Yeah, because there's a huge gap between these sorts of notions that we put into algorithms and the real world impacts. And that's part of what critiques of algorithmic fairness, including my own here, are pointing to, is that an algorithm can satisfy a notion of fairness that's pretty standard, and yet actually by many accounts be re-entrenching inequality. So if that's the case, clearly we can't just be relying on these definitions. We need to find other approaches.
Right. I thought that was because I thought that was the more powerful part of the piece, was to say, not that they're not helpful, but they could, by using them, be doing more harm. Like by relying on them, if we're kind of generating disparities in social and material resources, it's kind of reinforcing systematic problems that we have in society, then they're actually not that they're ever neutral, but they're not that helpful. They're actually harmful in some ways, like by relying on them too much. So I didn't know if you could talk a little bit about the move, which you pull on from formal versus substantive equality, as to how you see that difference and how you kind of take that conversation in formal and substantive equality and then bring it over to the fairness and algorithms discussion.
Yeah, so what I'm looking at so sort of thinking about where are the problems in how algorithmic fairness is conceived, and it's really two intertwined issues. The first being the issue around really trying to make this a mathematical problem and define fairness mathematically. The second piece being the limiting scope of treating fairness really as just a matter of inputs and outputs within a specific decision-making process. And that really maps onto ideas of formal equality, which are striving to sort of, create, sometimes this is quite similar to procedural equality, to create, fair procedures, decision-making processes that say, two people who are alike in terms of their input attributes for this decision should be treated similarly within the bounds of this process, and everything upstream and downstream of that decision-making process is ignored. And I think that sort of maps onto a lot of the issues that we can see within the formal approaches. And part of how I bring in substantive equality is by looking at how some philosophers and legal scholars have responded to similar types of tensions within efforts to promote equality that actually look a lot like the impossibility of fairness, where within a more formal frame of analysis, it looks like we're caught between these two completely incompatible ways of trying to promote equality. But actually, if we take a zoomed out approach, if we take a more substantive approach that looks at social hierarchies and downstream impacts and sort of the real world complexity of the situation, and thinks about reforms beyond just the scope of decision-making procedures, we can actually see that what looked like a fundamental tension is not so intractable after all. So I'm bringing in ideas from those scholars to say, here are some ways to think about how we might approach reform in these settings where it looks like we're stuck with a deeply intractable zero-sum dilemma.
So, and it's almost like as a visual, which I think this actually goes towards like other things with algorithms as to like efficiency claims and stuff like that, is that a lot of times we're looking in a very, very small box around just like the data that we've received, like, and then the model, and then maybe an outcome. And we're trying to, I'm using my hands and no one can see me except for Ben, but it's very, very small, and we're trying to optimize or figure out the fairness within that. So this is like the error rates being the same, or the true positives being similar for similar groups, or something along those lines. But when all of a sudden that's all the outcome, and how we treat people, how the data sets were actually created is actually embedded within this larger system that we need, if we kind of expand out to see what's going on, instead of just taking that as like a null and like a given. If we expand out to see what's going on, one, we're not going to use mathematical models for that, but also the problems that we're trying to solve might be different, and the issues that we might be facing with the data might be different as well. So our solutions and the problems are going to be different if we expand out. And that's similar to issues around equality, where we're trying to, I don't know, university admissions, where we're trying to like micromanage little tiny things about someone's application versus saying, well, who's even taking the SAT? Or like, so, and which schools are we even, like, kind of broadening out further to say what else is going on in society that we need to understand, how, instead of looking only at SAT scores, going more broadly and trying to understand what else is going on in the world to create the imbalances that we're seeing in SATs or GPAs or whatever that might be. Is that a fair characterization of kind of broadening it out?
Yeah, no, I think that captures it really well. And I think with respect to algorithms gets to this point around, are we trying to define these sort of mathematical formalisms about algorithms as somehow a property of algorithm, which maybe makes sense in some internal world? Or are we actually trying to figure out how we can use algorithms as tools for improving society? And if we're in the first world, then sure, we can define fairness, we can treat inputs and outputs and think about fairness as this mathematical construct. But if we're actually interested in real world impact, we have to look at what's happening in practice. We have to take this broader scope, especially because just relying on these mathematical notions of fairness, it doesn't actually lead to deeper equality when implemented in the real world. So we really have to think in this deeper way. And I think, there are a lot of lessons from ideas about equality and ideas about political reform and theories of change to draw on and say, why do certain types of reforms, lead in one direction and certain types of reforms lead in another direction? I think we can really pull on that, especially when we're talking about algorithms like pretrial risk assessments or predictive policing algorithms or welfare algorithms, where these are directly operating on these high stakes decisions and on people's lives. But also for the developers, a major motivation is that they are contributing to improving society. The goal isn't just to make a fancy mathematical tool for, theoretical computer science. They're working on an applied problem with an implicit or explicit normative goal behind that when they're developing these systems. So I think, it's important to carry that normative lens all the way through, not just to a high level motivation, but also to how do we evaluate what these tools are doing and whether or not they're actually working.
That's a great point, because I think like the idea of like what it means to actually work in the real world is one of those things that we just don't pay enough attention to, and that we need to pay more attention to. What I always say is, which is extremely odd, because in other places in an organization, or like when we automate a manufacturing line, we have to take into consideration all these laws and norms and like actually what's going on within the context to make sure that it's not creating problems in the manufacturing line, if it's not hurting employees. I'm not saying that businesses do this all the time, but they should. And so I think that it's just one of those things that we looked at whether it optimized or was efficient in this such a narrow, small little box, and not really understand in what way are there downstream effects, or even like what are the harms of additional true positives to someone who's is committing, or people think is committing, fraud in welfare. And especially since you look in the government context, it's always someone that's taking away someone's rights, right? So we have someone so it's like a higher impact on someone, and it's not really clear how we're measuring whether or not that AI is actually successful, or what success even means in that case. I don't know. Do you know April Williams? She does stuff on reparative. Yeah. So she has a workshop coming up this weekend on reparative algorithms, with that same kind of idea of looking at some sort of larger goal and not just trying to optimize on something kind of very narrow and small, but looking at something that's more of a social justice, repairing what's out there versus just trying to make whatever's going on faster, which is kind of where we are right now. So I don't know, could you speak a little bit about your alternative, which is, focusing on substantive? I recommend everyone look at Figure 2, which shows the role of, we don't have to go through Figure 2, but what I liked about Figure 2 is that I think it's a great, like, actual visual reminder of all the work that needs to be done around substantive ideas of fairness. Like, there's 3 times the boxes in Figure 2 around substantive fairness, and formal is really like an offshoot of a discussion. And so it really shows everything that we're missing by ignoring questions about substantive fairness and our kind of preoccupation with this one lane of formal.
So yeah, the approach that I describe in the paper is called Substantive Algorithmic Fairness, and I characterize it into 2 different types of responses. There's the relational response and the structural response. And we can think about this in terms of a more substantive diagnosis of the problem of even the impossibility of fairness, which comes up, almost first in Figure 1 as a sort of prelude to the second figure, which is more of a how might you implement this method in practice. But when we're looking at something like the impossibility of fairness, we can see sort of upstream and downstream issues that create this tension. Upstream of a decision-making process, we have what I call a relational harm. We have social hierarchies that say, there are deep inequalities in terms of educational outcomes, or how likely different communities are to be arrested or to commit crimes in the future. And, it's important to note that these are not just issues of the data being biased in the sense of misrepresentation, but also that the data is often accurately picking up on real world enduring inequalities. And I think that's an important point of this relational harm, where often we talk about the data's bias just to mean, well, the data's not, is misrepresenting the reality, but often the reality is deeply unequal, and the data accurately captures that.
Right.
So we can't just have the issue be that a concern about misrepresentation. So that's really this issue of the relational harm. And then downstream of a decision-making process, we have what I call the structural harm of what are the implications of the decision that the algorithm is informing. And typically, as you already hinted at, often these decisions are punishing individuals or restricting benefits from individuals who are judged negatively. So essentially here, downstream, we're re-entrenching the inequality that exists by saying, oh, you have lower SAT score, likely because you have because your social group was oppressed. That also now means that you, rather than getting support, you are now not able to get into college, you're not able to get this job or something like that. So we have the downstream harm that is further magnifying the upstream inequality. So if you think about this larger chain of a process, when we're just looking at the decision-making process itself, which is the case in formal equality or formal algorithmic fairness, we're not able to account for either of these concerns. And the goal of substantive algorithmic fairness is to bring both of these types of concerns into view.
I have to say, I was really impressed by how early you got to your answer and how much time you spent with it, because the vast majority of papers get to like, here's everything that's wrong with what you all are doing, and then implications and discussion. You know what I mean? Like, and so I want to applaud you for sticking with your solution as long and as detailed as you do, because every time you do that, you are like laying yourself out to be then later critiqued, which, I mean, even though we're academics and we invite that on the regular, like that's just kind of our job, it is not an easy thing. And I even looked at the number of like the pages and I was like, oh, you got there, and like by page 15, I'm already talking about your solution. And I was like, that's impressive, because I always tell people, get to the halfway point, talk about what you're going to do differently. And you did it, and you spend a lot of time with it and very detailed in applying it. So, I mean, it's one thing to propose, like, here's a way we can think about this. We should be thinking about this differently, even stronger. We should be thinking about this differently. And by the way, and this is how you would do it. Like, I'm going to walk you through what that would mean in a very specific case and kind of what the repercussions of doing that. So taking the compass idea, the sentencing algorithm, and then saying, like, what would that mean in this situation? What would it mean in other situations? And I think I really recommend that people read it, because even if you're not interested in it, just to see like how you can actually put forward an idea and then defend it, for a lengthy amount of time. I don't know what the reviewers said, but
it's funny. I appreciate that you picked up on that and enjoyed that, because I would say in successive drafts of this paper, and it went through many drafts, the positive agenda expanded and got larger and larger and started earlier and earlier, and the critique element got shorter and shorter, because increasingly it felt like, if the paper is more, there's a lot of papers that, helpfully point out things wrong, and then have a very brief section of, here are some high level steps forward. I've written papers like that too, but they don't give a clear positive agenda. And so, my goal was much more to provide that, which then means, you have to keep adding more and more layers to the positive agenda so that it feels fully fleshed out. It's always easier to do critique than, I think, to make proposals, but I'm hoping that this can be, hopefully now, as opposed to earlier drafts, it has enough meat on its bones, so to speak, that it's both, more to think about how it could be implemented in practice. Even figure 2 is something I added quite late in the process to really try to distill it down and to say, what are the actual steps that someone would follow here, as opposed to just sort of a higher level conceptual frame.
Yeah, I mean, it's not often you see figures in a philosophy paper. So kudos to that one as well, because I used to joke they wouldn't even know how to process it normally. So they probably were like, what is this JPEG? I don't even understand what this is.
We'll see what happens when I go through the proofs. I'm sure they'll have no problems, but.
No, I'm sure. The other, what it's a good reminder of, though, is that in some ways, there's this great philosophy of science, Richard Rudner, who talks about the value-ladenness of science, and people have applied it to technology. And the idea that he says is that, look, you're making these value-laden decisions throughout by ignoring them. So by ignoring your more substantive definitions of fairness, of algorithmic fairness, it doesn't mean that you're not actually taking a stand on them. You're just doing it, in Rudner's words, unmanageably. You're not actually being thoughtful about this, because you're inheriting them no matter what, and you're contributing to them, or you're interacting with them no matter what. It's a matter if you're kind of managing that interaction in the way that you deal with it on the front end, or, as your point, are you contributing to it later on downstream as well? And the visual, it really helps with that. So I will just say that I think this kind of summarizes your paper. The Substantive Algorithmic Fairness presents a new direction for algorithmic fairness, away from formal mathematical models of, quote, fair, unquote, decision-making, and towards substantive evaluations of how algorithms can and cannot promote justice, which happens early in the paper, but I thought it was a great summary of kind of what the point is, and also really focuses on the main point of the paper, which is to offer this new vision or different vision of how we think about algorithmic fairness, and also the role of mathematical fairness as a piece of the overall understanding of fairness. So we usually end with anyone that you know in the field, broadly construed about that we should be paying attention to. And this can be from any discipline whatsoever. I'm very agnostic to discipline. So if there's anyone that you really, when you think, oh, I can't wait to see what they write about next, is there anyone we should be paying attention to?
Absolutely. I think there's, a number of people that I think are really doing interesting work at the intersections of AI, ethics, race, and the real world social impact. So Rashida Richardson is one who's a legal scholar at Northeastern, and she writes really great articles about sort of the role of race in how AI is used in police departments and government bodies generally. Anna Lauren Hoffman is at University of Washington writing some of the critical articles on fairness that I referred to and cite in the article, but really pointing to the gap between these sort of abstract ideal conceptions and some of the real world issues of inequality. Lily Hu is a friend who is a philosopher at Yale, writing about issues of race and social science and AI in terms of how we construct race and issues of causality that I always really enjoy reading. And then Rodrigo Ochagame, who is a professor at the University of Leiden, writing about, similarly to many of the others, about the limits of AI ethics and AI fairness and trying to bring in more of a historical approach and STS approach and anthropological approach to understanding where do these conceptions come from, what sorts of impacts do they have when deployed by political actors and engineers into practice.
Oh, that's great. Well, you covered your base. I saw when you cited Anna Lauren Hoffman. I love that paper of hers from a number of years ago where she really just takes it to task on the focus on discrimination. And it was just so pointed and on point that it's so refreshing to have someone just kind of tackle that straight on. But thank you very much. That's really helpful. Well, thanks so much for being here. I really appreciate you taking the time out of your day. I know it's super busy. So thank you very much.
Yeah, thank you so much. This is a great conversation. Thanks for having me on.
TEC Talks is a production of the Notre Dame Technology Ethics Center. For more, visit techethics.nd.edu.